Here's a slide of some hyperlinks that are useful for acquiring the two freely available programs at the top. An account with Amazon AWS is also needed because there is a small charge for using the Amazon server with the SPS software. Amazon AWS has hundreds of other computer services available that you may also find useful in your work. The first step, acquiring good LCMS data, is the most important. MassSpec cannot help you with that, but here are three excellent references on setting up data-dependent acquisition parameters for LCMS. The 19 raw data files from the second reference will be used for this demo. These roughly 40,000 MS-MS spectra are environmental surface water samples. SPS can handle both positive and negative ion data, but not data that is collected in alternating scans within the same run. To keep the video fairly short, I'm going to demonstrate MS Convert with only one sample file. Okay, I need to find the file. Bring this over here. And then I can add it in. I could have a large number of files. The output directory will be the same as the input directory unless you choose to change it. I'll do the full scan MS data first. So that is MS1, and the extension I want to use is MS1. Go with 32-bit, and I don't want to use any compression. So this part is pretty well done. If we go over here, the first thing I do is I remove anything that's in there already, and I start with the peak picking. I always start with that. And vendor is the algorithm that I want to use. And for full scan, it's MS1, if you will. So let me add that in. And then the second thing is a threshold peak filter. So this will save a certain number of the most intense ions in the full scan spectrum. I'm going to use a fairly high number, 500, because I would like to get the isotope data from this. Okay, I've got that, and then I can say start. So this was one LCMS run that was done in the DDA mode, and in DDA what you basically have is a series of cycles. So first the instrument does a full scan and picks out a few precursor ions if they're above a certain threshold, and then it selects those precursors and does MS-MS on them, and then it repeats that cycle over and over. So what we're doing here is we're extracting the full scan data from the whole file. So that's done. Now I want to use the same file or files, and in this case I'm going to use MGF. It's a common proteomics output or generic file format, and this is the MS-MS data. Use the same parameters here, and again I want to remove these and start over with peak picking, and I want vendor. And MS-MS is like MS2 is another way of looking at it. So I'm going to add that. And then again, we need a threshold. And the MS-MS spectra, we don't have to worry about isotopes. So I'm just going to use 100 here. It's usually fairly clean. And again, start. So the outputs are going to be in a text format with masses and then a tab and intensities. Although we're separating the full scan data here from the MSMS data, they're closely linked by the exact time at which these spectra were taken. So of course, we can relate one to the other. We also, the MGF format for the MSMS includes the mass of the selected precursor ion, but some of the vendors don't do a lock mass correction, and they don't apply that lock mass correction to the precursor ion. So to be safe, we take that mass from the full scan data, which is after the run, it's corrected for lock masses. Okay, that's done. At this point, I can I can close out MS Convert, and I want to go to the file. So this was the data, a Agilent data file. In this case, it was about it says 1.06 gigabytes. I'm going to select these two. I don't care which one is which, but they have the same name. And I want to send it to a compressed file. So that will tell the SPS that these two are a pair, if you will. The next thing, we don't see the suffixes in Windows, but I want to add a prefix, rename, and this was positive ion data, so I'm going to say POS dot. So we need that prefix of pos or NEG for negative, so that the SPS software will know whether the data that's being processed is positive or negative ion data. Thank you for your attention.